Yeah, tell me please, what we discussed in the last session?
Discuss about execution plan.
Correct. Execution plan. We discussed a lot of things, starting with servers, server designs, models, kind of thing, right? So desktop and server comparison, and then we move to database server components we discussed, and in that again, what we covered up, we started discussing about user process, and server process, how it processes your queries, correct? The stages, the first stage it will do, that is parsing, and then it will go with the execution plan, and the last is the fetch, correct? Yeah. Okay, let me just draw the same our instance, that is your SGA and a set of background processes. Now SGA is mainly divided into three main components, correct? What is that? One, buffer cache. Another is redo log buffer, shade pool. What others, please? Large pool, Java pool, and streams pool. Correct? Now tell me the background processes.
DB writer.
How slow you became now. After 2 days, you nearly forgot a lot of content. No? Please tell me that. Yeah, please. DB writer. Yeah.
Log writer.
Log writer.
Checkpoint.
CKPT checkpoint.
PMON.
SMON and PMON. So please go through the previous sessions once again, and once again. Do it minimum 2-3 times so that it should be there in memory. Why? Again, I'll tell you the same way as I'm asking you guys to do. The same way Oracle architecture is also there. You'll be understanding it soon now. Right? Go through the things, whatever we discussed. So we understood about the process. What is this process? A server process on the client side, user process on the client. Then also we started discussing about the files. We got one of my file which contains a set of tables, correct? Which we call it as a data dictionary tables or base tables, correct? Which contains what? Metadata and statistics. Correct? Now, shade pool is divided into two main cache. What is that? Library cache, and another is a data dictionary cache or cache. Done? Whenever you submit your query, whatever the query example, select, I'm not writing complete syntax, please follow me. Select like employee number, name, comma job, comma sal, right? From EMP, right? Where employee ID equal to 101. Correct? This is the query I'm going to submit. Now, whenever you submit the statement, it is doing what? Doing the first parsing the statement, and the second one is execution plan, and third operation is called as fetch. I'm just writing the short keywords here, right? Follow me. So now parsing, when you submit the statement, what happening? Parsing. What do you mean by parsing? Your syntactical check, select from where semantic checks are done here, right? Table exists or not, columns information, everything going to be verified, users, permissions, done. Once parsing is done, then it will go with what? Execution plan. Right? Execution plan. Correct. In the execution plan, what is coming up here now? We are getting the optimizer. Right? We are having an optimizer, an engine optimizer. What it will do? It will take two levels of statistics. What are those?
System statistics and
object statistics. Another is
system
statistics. Object statistics and system statistics are used, right? Then optimizer will come up with multiple access paths, right? Out of which one is selected as a execution plan
Plan.
based on cost.
Cost.
Just trying to refresh, right? See on the board, please close your books. Close your books on the board. Now, as this user submitted the query, see, I'll be reframing the things multiple times so that it should be there recorded properly. Second, every time I do some change in that, might be you're not noticing that, but I know I'll be doing a change. Slowly, I'm going to enhance the radius. Correct? Slowly, I'm enhancing the radius explanation in that. So please be with me, don't miss. So when a query was submitted, first what it is doing, server process parsing. To parse the statement, syntactical, semantic, it needs what?
Metadata.
Metadata.
Metadata. So IO, yeah, metadata. Thank you. IO is done, and your metadata is loaded. Metadata. Using that, your parsing is done. Correct. Second, execution plan optimizer. He needs the statistics. Again, the statistics are again loaded from here, right? So you got the statistics here. Statistics. Now, using the statistics, optimizer will come up with an execution plan. Done till this point? Yeah. Now, once the plan is generated, right? Now, server process got the plan. What is the plan? Might be a table scan or an index scan. Correct?
Yeah.
A table scan could be a full table scan, or it could be an index scan, or if you have any other dependent objects which are used in avoiding full table scan, that might be selected. Fine. Okay, now let's say if it is a full table scan, let me draw the files again. What is this file named as? This file, what you see here, it is named as, it is a data file. Which file I said? What is that? System.dbf.
DBA.
System.datafile.dbf will contains your data dictionary tables, base tables, in which you have all your database metadata and statistics are stored in it, which are used basically in parsing and execution plan. Done. Next, we seen there are a few more other files we have. Fine. And there is one more, 1, 2, 3, 4 files I drawn, right? Okay. One more file here. Let me keep it here. This one. So this file actually contains your tables. So same previous example, your EMP table, 10 blocks. Index, we got to 2 blocks. I have one index on EMP number column. Which column? Employee number, employee ID, employee ID or employee number. I'm using a number here, employee number, and we have one more index on which column? Department number.
Department.
Correct, please recollect. Yeah. So like this, you can have multiple indexes on different columns on your table. Table is the base for everyone. Once you have a table, then you can have n number of indexes. Again, indexes is again a very good, interesting, a big topic, a separate topic, right? There are different types of indexes are there within that again for different requirements. Please. Okay, indexes. You understood what is the basic purpose of index, correct? Done. So parsing is done, then execution plan generated. Now let me just proceed further here. After execution plan generation, server process, what it will do, what is this area? Library cache. Let me write it here, library cache. In library cache, some memory area gets created or allocated or taken, right? Where your server process is going to keep. Let me just make it little bigger. Memory area is taken in which your statement, what is this? The SQL statement, whatever you submitted, right? The statement gets stored, then your parse code and
execution
plan gets stored. Where it is getting stored? Inside your library cache, right? Now this piece of memory area is called as, what is that? Cursor. Called as cursor. Done. Now, once the query is submitted, first I'm going to do the parsing, then generate the execution plan. Then after generating execution plan, I'm going to create a cursor, take memory area, chunk means a piece of memory area, and in that I'm going to store the statement, parse code, execution plan. Furthermore, internal information, fine. But mainly like we see, okay, then this memory area, chunk area is called as what? A cursor. Once this is done, it will follow with what next step? Fetch means what? Follow the plan. What is the plan saying? Full table scan. Okay, fine. Let me go to the table, bring this table here into which area I'm going to actually load it here? Into buffer cache. So I got the table blocks here into this memory area, right? And then it will do a scan of all these blocks. Finally, whatever the employee number 101 I found somewhere in a block, I'll take that value, that columns, and I'm going to return it back to the user. This operation is called as what? Fetch. Understood? Followed? Okay, please, let's refresh, right? Parsing, to complete parsing, statistics are loaded here. Sorry, metadata is loaded. Parsing is done. Statistics are loaded, right? Optimizer came with an execution plan. And after that, your table data is loaded and your rows are selected, specific rows and specific columns and rows, selected rows, and returned to the user. That operation is called as fetch. What do you mean by fetch? Fetching data and giving it to the user, server process, right? Taking data and returning any data to the user. That operation is called as fetch. And mostly fetch operation happens in selects. Because when I do a insert, what server process will do? A user gave me an option, right? Command, insert data. Okay, I'm inserting data row into a block, done. What I will do after insert? I'll say one row inserted. I'm not returning any data. I'm simply acknowledging, yeah, I'm done. Just a acknowledgement given. It's not returning any data. Get my point? Yeah. If you do a delete, it will say one row deleted. If you ask it to do a create table, table created, drop table, table drop, create user, user created. Only acknowledgement is given in your DMLs, DDLs, what are the commands, all of those, only the acknowledgement is given. Correct? Only the acknowledgement is given. Select basically will have what? Fetch operation where the data is taken and returned to the user. Is it done? Everyone clear? Shall I proceed now?
Yes.
Till this point. Any questions, anyone? No. Statistics are different. Right? Statistics are different. Yeah, it's actually different. It's a type of data again. Metadata is information. That statistics are different. Metadata is nothing but data about your data. Right? Both are different. Okay. Done? Right. So the file where I have my tables, indexes, let me give this file also a name. Let me call it as users.dbf. So system.dbf, that is my system data file, contains my data dictionary table. Users data file, I have my tables and other objects. All my users created objects are in a separate data file. Done? Now, we got this memory area, guys. Now, why? What is the use purpose of this memory? Simple example. Last session, right? I gave you some value mathematical. What is that? No, mathematical calculation, something plus. I asked you something, right? Dash plus dash equal to. See? What is that? 10 plus 10? Remember or not?
Yeah.
Correct. It's there in your memory. Yes or no? Immediately to retrieve. Correct. Okay, if I gave a note something like this to write it down, and if you forgot, what happens? Give me a minute, sir. Let me check. You'll go through those previous pages. Somewhere you would have noted down and then say, yeah, sir, it is 10 plus 10. Correct? From memory, getting it the value 1. The second is going through the papers and getting the value, which is faster. If it is there in memory, you answered me immediately. The next second you answered me. But going through the book, will it take 1 second to answer? No, right? It will take, might be couple of seconds, 3, 5, 10 seconds to find out and then get it. time taking process. See, always remember data is on the disk. Data is stored inside the files and the files are stored on your hard disks. Remember, hard disks are really slower. Slower means it takes time to get data from the hard disk. It's not that fast. RAM is the fastest component next to CPU in your server. CPU is the fastest one, brain. Right? The RAM is another one. Accessing from RAM is really faster than accessing it from the disk because the files are stored on the disks. Oracle, what it is doing when you fired the query submitted, all the required, this table user related metadata is loaded here. The statistics of the table is also loaded here and the table is also got loaded here. Correct? Kept in the memory, different areas. What happens now if the same user submits the same statement again after few seconds? After few seconds, what that user did, copy that line, paste it again. Right? Or normally we do /enter to execute the previous statement. Now, just question for you. If I say /enter or copy this and paste it again and give it to the server process, do you want server process to again do what? Parsing. Do you want the optimizer to be used and generate a plan? Do you want to go with all the stages? Tell me please. Yes or
No.
no? No, we don't want. If it is going through, let it go, but it takes time. So again, parsing means again metadata it has to check. There are not in memory. If it is not there, load it. So what happening here? An IO is happened. An IO is happened. Here also an IO is happened to load all this data. Correct? So Oracle is really very smart. Now what Oracle is doing, see again I'm trying to reframe the story. What is that? Whenever a query is submitted to server process will actually first go and check. Let me change the color. First it will go and check where in this area. What is this area? What is this area?
Library
Library
cache.
cache. I am going to simply go and check in the library cache. Whenever you submit a statement, I am going to check in this library cache. What is this? This is a memory area where your statement is stored. Correct? Now, it's not about only that one statement, right? There might be so many users connected, so many sessions. For every user, a process, server process. Might be the same user would have submitted different statements. Select column 1, column 2, column 5 from DPT table. Getting my point? Might be he gave another statement, select column 1, column 2, column 3 from, right, bonus table something. Correct? And also might be he would have said select column 1, column 2, column 3 from EMP only, but where what is that? Department number equal to 10. This is different. This is different. Correct? So each statement, whatever the user submits, they are all unique or not? Are they same or are they different? They're all easily by our naked eyes itself we can identify, yeah, they're all different tables, different columns, queries. Each query you submit, not by one user, by every user submitted, they all will be, once the parsing is done by the server process, every server process will do first what? Parsing, and second execution plan. Then what it will do? It will create a cursor here in which area? Library cache, and your statement parse code execution plan, statement parse code execution plan, statement parse code execution plan. Like this, all your SQL statements, their parse codes and execution plans are stored in which area? Library cache. Got my point? Now hundreds of statements you can see there stored inside the library cache. Inside what? A cursor, a piece, a chunk of area. Done? Now, when I submit the same statement again, right? Let me go with the same statement part. When I submit the same statement, generally what happening now? First thing it is going to check where in the library cache is the statement submitted or not. I'm going to check. What I'm doing here now, I'm going to do a check that it is already executed or not, or submitted or not. Check available or not, where check in the library cache. So will it finds? If it is no, or might be it has found it. So this is my first thing. I am going to do a check in the library cache. Got my point? Please. Okay, let me reframe. See, again, I'm going to divide the story into small pieces. Right? So please, at the end, they're all going to be related. But again, I'll be jumping from here to here. Again, this topic here, this topic here, they're all related. Because I need to explain that and then I can make a match of them. Right? So please be with me. That's why. Important. Right? So let's say the statement got submitted for the first time. This is the first time this user has submitted the query. It's not like copy paste did. No, it is the first time. When you submitted the statement, now one thing you understood, any statement you submit for the first time or multiple times, whatever it is, his job is to first to go and do what? Understood? Now let's say, and let's take an example, it has submitted, it got submitted for the first time. What I will do, server process will go and check in the library cache. Do we have the statement? Will it find the statement there? No. After scanning the library cache, right, I didn't found, so no. Then what should I do? If it is no, then go with the second step. I hope you're able to see the numbers. Correct? Second, what is the second means? What is that? Parsing. Go with the second stage, parsing. Now in the parsing, what it will do? It will do an IO. For doing a parsing, what it required? It requires metadata. It will check where the metadata inside the do we have. If it is not there, it will do an IO and load this metadata and then complete the parsing. Is it done? Once parsing is over, next what is the stage? Execution plan. Let me give number 3. Then once parsing is over, parsing might need some IOs and finally done. Execution plan means what? Optimizer comes in picture. Yes. There again IOs are done, generates the plan and finally stored into the cursor. In the form of cursor, it gets stored. That's all into the execution plan. Now in the execution plan, let me give the numbering event. Execution plan. Let me say it is going to check the statistics. Who optimizer comes in picture. That is my 3A. Done. Okay, 3A. Let me give boxes here. 3A, part of 3, right? Then this is going to be correct. Using this plan, then finally what? 3, C. And let me add the in the 2 also 2 parsing done. To do the parsing, syntactic, semantic, syntax, anyhow done semantic, it will do this one, IOs, right? What is this IOs called as now? 2A. 2A. Yeah. 2A, right? 2A loaded and using that it has done. In 2 you have 2A. In 3 we got 3A. Let me give it capital A, 3A, 3B and 3. Is that correct? Yeah. So this is my number 1 and this is my 2, number 2 and this is our 3 execution plan and cursor done. After that it will flow, go with what next operation? 4. Fetch. That is a fetch operation, right? 4, that is a fetch operation. In the fetch operation, what it is doing? Fetching means taking data and returning. But before that, it has to do what? IO to load it. Correct? Okay, let me give this number as what? For fetch operation itself, I'll give it as a 4, means IO and load this data, and this fetch returning it back is called as what? 5. Returning it back as a 5. Got my point? Okay, let me just go through the numbers again. So first, when the query was submitted, check in the library cache, didn't found any cursor related to that statement, then follow with the 2, go to the parse, do the execution plan, done, cursor created, done. After cursor creation is done, stored. Now I got the plan. So server process should follow the plan. Yes or no? Yes. In between, I will add one more line here. After this, I am going to do, what is that next? What is that? Check. Where I am going to do a check?
Buffer cache for
Buffer cache. I have to check in buffer cache that do I have the table blocks already there or not?
yeah.
Correct? So what is that again here you get? S or no? I didn't found any. So after 3, let me give the numbering here. Checking buffer cache is what? 4. Correct?
Loading.
After execution plan, check in buffer cache 4. Have you found? No. Then what I will do? Load the data from disk to memory. So then the number will be what now here?
4A.
It is going to be 5.
4A.
After loading all this data, take the value from here and return. What this value will become? 6. Then reframing. Hope it's good, clear, right? Now, do the same. If the query is already submitted earlier, right? So we got a cursor here now, and also the table is already loaded. The same statement, if it is got resubmitted, copy paste, what happens? Same again, if I resubmit the statement, server process, what it is doing first, it is going to check. Will it find the cursor or not here? Yeah, it finds the cursor. So what it will do? Simply use the what? Execution plan. Use the execution plan. Already I got the plan. So I found it here. Yeah, I found S, right? I found the execution plan or not. So once I got execution plan, what I will do?
Check for the
Right. So what number I have to use here? I'm going to simply skip parsing and regenerating execution plan. Avoid it. If it is already there, no need to parse. I can reuse the parse code and go through the execution plan. Once I got execution plan, what is the next one? Check buffer cache. Yes or no?
Yes.
If it is S, that means the table is already there. Simply go and scan the blocks, take the value and return. What I have to do? Number 6. So if it is S, I am going to do 6. Correct? If it is no, I have to do 5. If it is no, I have to go to, if I didn't found it here, then again I'm going to load all the table data, scan and take the value and return. Correct numbering? Please understand, if I resubmitted the same statement again and again, what is happening? First, I'm going to check in library cache. As I found it already, I'm simply jumping to check where? Buffer cache. As I found it already here, what I'm doing? I'm simply taking the value from there and returning. So I found the parse code, execution plan, and also my table data in memory. Yes or no? If I don't have anything, then I will end up doing what? Please tell me. IO. If I don't have the table, I have to load this table again into memory. The second time when you submit the statement, it is going to be faster. Why? Because it is reading it directly from the memory without doing any IOs. You're able to answer the question dash plus dash equal to. It might be he didn't answer. So what he will do? He forgot. So what he will do? He will go through the book if it is written. So he's doing an IO because it is not there in the buffer cache. If data is not there in the buffer cache, wait a second, let me go through, do an IO, that will take time. Going through a book again obviously takes time. So after getting the value, you are going to answer me. Correct? Now, when you are answering what you are doing, you are loading it in memory. Now, again, if I ask you the same question, what is the dash slash dash? Tell me now, sir. Correct? You are able to answer it immediately. Why? Because now it is available in memory. So, whatever data is loaded in memory, it will be maintained for some time, maintained for some time. Make sure it is maintained for some time. So that if the same data requested again and again, it can be directly served from the memory without any IOs on the disk. Got my point? Understood? Is that clear, please, everyone?
Yes.
Right. So now, parsing, execution, fetch, the stages also you got here. Yeah. You can make a note of this better before I change. Now, same again before that, the rule applies same for everyone, right? Any statement, any session, because each user connected is a session. Each connection is a session. Each session, whatever the statements they submit, number of statements. Please wait, don't write. Whatever the number of statements they submit, they all get their statements, parse code, execution plans are stored inside the cursors. Correct? And the table data is loaded and kept into the buffer cache. Now, how long it will be there? No, there will be a FIFO mechanism. What is that? First come, first out. It is a limited area. What is the size? Normally, if I give my SGA size is like a 10 GB, out of 10 GB might be, I will say 5 GB is my shared pool. Out of 5 GB divided into 2, that means 2.5 GB, 2.5 GB or 3 GB, 2 GB. So nearly 3 GB is my, what is that? Library cache, just basic calculation. Okay. So it is in GBs generally. Correct? Minimum 1 GB, 2 GB, 3 GB area. In that, just you can imagine how many cursors can be created. Right? If it got filled up, then what? If a new statement coming, it will override the previous one. Previous means the first one. Correct? So if a user says complaints, or if you found the queries are not reusing the things, they are doing lot of IOs every time, might be, if it is the same statement you are submitting, might be every 10 minutes I submit the statement. So that means the statement should be available here for 10 minutes. But if what happening at 8th minute or 9th minute, it is getting overwritten by some other statement. It is simply overwriting. Because there is no area, there is no enough memory, it is getting overwritten. So in that case, make sure you have enough memory area, increase the memory area. Tuning, that's called database tuning. Why your queries are slow, right? IO, see always guys, IO is the main culprit, right, in performance, right? If even your laptop is slower, check out, IO is the main culprit there, not the CPU or not the memory. CPU is used in doing IOs. Right? There could be some IO activity happening that will make down your system slow, because storage, the disk is the slowest unit in the system. CPU is faster, memory is obviously faster, storage is only the one which is slower. Got it? Yeah. So what I'm saying here now, every user who is submitting their queries, they all will be stored here, and only thing that every time when you submit, it will go and check is it available or not. So your job will be what? Make sure your statements are there, are staying for a very long time by maintaining a good enough bigger, larger memory area. Done? Second example, this user submitted the statement. So statement parse code execution plan available. Now the another user is also submitting the same statement. Same or not? Same statement here, the other user also submitted. What happens now? For that other user also, he is going to check, is the statement there? Yeah, same statement already there, but not by the same user. No, do I need to do the parsing? I don't need complete parsing. What is parsing? Means syntactical semantic checks. Already syntactical checks are done. Next is what? Semantic checks, right? What do you mean by semantic? Table exist or not, column exist or not, user permissions. As table columns it can skip, but this is a different user, another user who is firing the same query, same table, correct? So that user level checks it has to do. The minimum checks will be done, so that is not considered as a complete parsing. So it will simply do a very small checks and then follow with the plan. So other user, other sessions, even if they are submitting the same statement, they all get the same execution plan to follow. So we are not regenerating the parse code, we are not regenerating the execution plan. Reusing, that's why this memory area is called as, what we call this whole memory area? What do you mean by SGA? System global area, or even we call it as a shared global area. Shared, right? The same content, whatever is there belongs to the user one, it can be used by other users even. Shared by multiple users. Shared global area. Done? Yeah, please make a note of this.